This is a video on solving linear inequalities in one variable. Let's get started here. Let me just say, recall. This symbol here, if you see it, means greater than, right? So the number on the left would be greater than the number on the right of it. This symbol means greater than or equal to. Alright, this would mean less than. So the number on the left would be smaller than the number to the right of the symbol. And less than or equal to is that symbol there. So, when we talk about linear inequalities, we're going to use these in place of where an equal sign would be. And then, in one variable means you only have one variable in the problem. The idea is to solve for the variable, in terms of what would make the original statement true. So just doing a small example here. If I ask to solve x minus 6 is greater than 10. You really want to solve it in a similar way that you would to an equation, which means that if I say x minus 6 is greater than 10, the idea would be to isolate x on one side of the equation. Typically, in this case, we're going to isolate it on one side of the inequality symbol. So because the x is already on the left, I'm going to isolate x on the left side here. So if I wanted to do that, I would add 6 to each side, so it would cancel out over here. And we end up with x is greater than 10 plus 6, which is 16. So when you solve this, right, x is greater than 16, what it's really doing is it's giving you the interval of values where this original inequality is true. In other words, numbers for x that are greater than 16 would make this original statement, x minus 6 greater than 10, be valid, right, be a true statement that would hold. So, you could think of numbers like 17, 18, 19, right? If I was doing 17 minus 6, that would make that 11. 11 is greater than 10. But also keep in mind that, anything greater than 16, even 16.01 minus 6, right, will give me 10.01, which is greater than 10. So this means all the numbers greater than 16, even, as close to 16 as you can get without touching it. So, one way we express these solutions is on a number line. So if I was looking at a number line here, I'm not going to put all the values on the number line, but 16 is a value on the number line. And what we're going to do is we're going to say, all right, do I include 16 as part of my solution? Well, this is for x is greater than 16. So since I'm not including 16, right, because only x is greater than 16, 16 doesn't make this true, right? 16 minus 6 would make this 10. 10 isn't greater than 10. So we're going to put an open circle on 16, meaning I'm not including it. All right, if this was a greater than or equal to, you would include it, but since it's just a greater than, you wouldn't. So we're going to have an open circle on 16. I want the x's that are greater than 16, or the numbers, right, that are greater than 16. Well, those numbers are to the right side, right? Numbers that are bigger than 16 are to the right of it. So on a number line, this would be my solution. You may have seen this colored right on the number line before. I like to do it above just so it's easier to see. But on a number line, this means all the numbers greater than 16, but not including 16. That's what the open circle means. Let's take a look at another one. If I said to solve 2x plus 5 is less than or equal to 11. Again, to solve this inequality, I want to isolate the variable on the left side here. So to do that, I have to move the positive 5 first. So subtract 5 to cancel that out. If you do it from one side, you got to do it to the other. So we end up with 2x is less than or equal to 11 minus 5, which is 6. And then we'll divide both sides of this by 2 to isolate x. So you have x is less than or equal to 6 divided by 2 is 3. Make sure you keep this an inequality symbol as you're solving. Don't make it an equal sign because it's not. So what we found, right, x is less than or equal to 3 are the values for x that can be substituted into the original statement that would make it true, that would make it hold. So this case, when I say less than or equal to 3, that means 3 is okay, because if I put 2 times 3, that would give me 6. 6 plus 5 is 11. 11 is less than or equal to 11. It, matter of fact, gives you the equal part of it. When we say this is or equal to, it's one or the other, right? So it's less than or equal to. Any numbers less than or equal to 3. So numbers just below 3, like 2.99999, also makes this true. But anything less than 3 would make it true, and including 3 would. So when I go to draw the number line that goes with it, again, you don't have to put all your values on the number line. Just make sure we put 3 on here. If sometimes they give you a number line that already has 0 on it, make sure you put 3 on the correct side of it. And, you know, am I including 3 in my answer? Well, the equal to tells you that 3 is okay to use. So if I am using it, I'm going to fill in that circle. So a solid circle means you're including it. An open circle, like we had above, means it doesn't. In other words, if there's an equal to with it, use a solid circle. If there isn't an equal to on your inequality, use an open circle. So we want x is less than or equal to 3. Well, where are the numbers that are less than 3? That's what that really means. X is all the numbers that are less than or equal to 3. Well, that would be to the left. That's where the smaller numbers are. And that would be your number line. So just kind of as a rule, right, if you're talking about open or closed circles, you use an open circle when you have either a greater than or less than with no equal sign. You use a filled in closed circle if you have an equal to with your inequality, a greater than or equal to, or a less than or equal to. All right, so make sure you know the difference there when you're going to draw your number lines. All right, we'll also talk about different ways of expressing your answers. You might have heard of set builder notation before. We'll write a couple examples using that. If I said to write each solution in set builder notation. And we'll kind of just use what we had before. So if I was going to write x is greater than 16, right, that's me giving you the given part. It's really just the answer we had above, right? X is greater than 16. And then the solution for this in set builder notation, would be, you know, for sets, we always use a curly brace to start, right? That represents the set. And then we put the variable we're using. In this case, it's x, could be other variables. So this is the set, and really it means of all x. We put this bar here. The bar means such that, and then we put our condition, which in this case, x has to be greater than 16. So x is greater than 16. All right, and then close the curly brace. So this is the set builder notation. It means a set of all x such that, and then we just put whatever the statement is for our solution. So a set of all x such that x is bigger than 16. That's how you'd write it in set builder notation. All right, so this is set builder notation. Just making sure we see it. If I said x is less than or equal to 3, writing this in set builder notation, first thing you need is the curly brace. You know, try to draw it as best as possible. Just make sure you know it's not a parenthesis, it's not a bracket, it's a curly brace. The variable, in this case, x. The bar, that means such that. And then our condition, which in this case is x is less than or equal to 3. And then close the curly brace. So it's the set of all x such that x is less than or equal to 3. If you're doing this in my math lab, I know they provide the curly braces for you, but if I asked you about this on a written assignment, you have to write the curly braces there to get full credit for the set builder notation. So it's not really too difficult to write set builder notation. I mean, you have to remember the curly braces, the variable, the bar that means such that, and then whatever your condition was for your solution. Another way you might be asked to write your answers is what we call interval notation. We'll look at this a little bit more closely in a second, but if I said to write each statement, or each solution, I'll say. In interval notation. So it's just another way of writing your solution, right? We just saw set builder, so this is interval notation. And let's do the same ones we just saw. So if I said x is greater than 16, remember the number line that went along with this? Sometimes it's helpful to see it, just because it helps you write the interval notation. So I have 16 here. And then remember, x is greater than 16 means I'm not including the 16, so I have an open circle there. For x is larger than 16, I'd be talking about everything to the right, right? X greater than 16 means x is bigger than 16, bigger numbers are to the right on the number line. So for the interval notation, when we take a look at this, we really want to represent this interval that covers all of the x values that are where we shaded. All of my values start at 16 but don't include 16. So when you do interval notation, I have a little handout here. And, what I really want to write here is if I have brackets, right, square brackets, you use that if the endpoints are included. That's what this says here, right? So this is saying that the endpoints are included. So if the number at the end is included in your solution, you want to use brackets. Typically it'll happen if you have an inequality that has an equal to in it. And this is, parentheses if the endpoints are not included. So, typically you'll use that when you have just, a greater than or less than. So for the example that we just, are looking at, when I wrote these here, A and B are just, values on your number line. X is the variable still. So if I had x is greater than 16, that's really, falls into this x is greater than a, right? If I said x is greater than 16, well, how would I do this? Well, I want to start from left to right always when I look at this. So from the left, instead of this being called a, we're going to call it 16, right? We had an open circle at 16 and everything to the right of it. And I want to write the interval. Well, the interval starts with an open circle, meaning I'm not including. If I'm not including, I use a parenthesis. So when I go to write this, I'm going to start with a parenthesis, and then the value I start with, which is 16. And then I want to say, well, how far out to the right does this go? How far does the interval go to the right? Well, this interval goes on forever. If it goes on forever, we call that infinity. And infinity looks almost like a sideways 8. Sometimes people think about how you'd make like a fish as a kid, but make sure you connect this other end, right? So it's like a sideways 8. So 16 to infinity. And you never can attain infinity. It's more of an idea that it's saying the numbers go on forever. It's not an actual value you can get to, so it's always a parenthesis on the side with the infinity because you can never include it because you never attain it. So this would be the interval notation. All right, so parentheses 16 to infinity parenthesis. And that, remember that first parenthesis because I'm not including the 16. You always look at this from left to right. And if you look back at the other handout I had, that's really what this showed, right? It showed x is greater than 16. You start at 16, go out to infinity. So parentheses, a is our 16, goes out to infinity. All right? With the side with the infinity, you always use parentheses. And then we'll take a look at the other one. If I said x is less than or equal to 3, the interval notation for this, is helpful to see the number line first. I usually write a number line even if it doesn't ask me to because it helps me see what my solution would be. So for x less than or equal to 3, remember the equal to tells you that you are including 3 as part of your answer, so I want to close circle on 3. And then the x is being less than or equal to 3 tells you want to shade to the left because smaller x values are to the left. So I'll put an arrow going that way. And that was a number line, right? That's not actually what the question's asking. It's what we just showed above. So if I wanted to write the interval notation for this, all right, the interval notation for this says that you want to look at it from left to right. Well, how far out to the left does this go? Well, it goes forever to the left, which means that if it's going forever, you're going towards the negative side of the number line. So that's negative infinity. Remember, you can never attain negative infinity. You can't get there. So I'm going to start with a parenthesis, negative infinity. And then I'm going to say, okay, well, it starts at negative infinity. How far to the right does it go? Well, it goes all the way up till 3. Now, do I include 3? Well, it has an equal sign, right? It's got a closed circle. So that closed circle, you're including it. Remember, use a bracket if you're including it. So use a square bracket there if you're including the value. Use a parenthesis if you're not. So we're including the 3, so we put a square bracket on the 3. Remember, you only put the bracket on the side that you're equal to. You don't put it on both sides of this. So it really just follows the same set of rules. So the interval notation here would be parentheses, because you can't include the negative infinity. From negative infinity all the way up till 3, including 3 with a bracket. So we'll do several examples where we kind of show all the notations. Typically you'll be asked about one or the other. Sometimes you'll be asked about a number line, sometimes you won't. For most of these examples I'll show you all the different types of notations just to make it easier to work with, so you can see the different solutions that are possible. So if we take a look at a couple more examples. We'll say write each in set builder notation, interval notation, and on a number line. You don't necessarily have to do it in this order, but it might be helpful to see it. So if I had something like this, so for the first one I'll say x is less than -8. First thing I'm going to do is draw the number line. So for the number line, just because it's the easiest thing to work with really. So for the number line, I'm going to draw the number line, make sure you put arrows on the end, it does go on forever in both directions. Put the value that we're looking for, so -8. And then you have to ask yourself, do I include -8 in my solution? Well, that means, is there an equal sign in this inequality? And there's not, so that means that we're not including it, so we need an open circle. And we want x values that are less than -8. When we say less than, we mean smaller than. Well, values that are smaller than -8, they're going to be to the left. Alright, so that's the number line that goes along with this. We were also asked to write interval notation and set builder notation. For interval notation, taking a look, usually the number line helps. So how far out to the left does this go? Well, it goes out all the way to -infinity. So can I include -infinity? The answer is no, so I need a parenthesis, -infinity. And how far to the right does it go? Well, it goes all the way up until -8. Do I include -8? Well, open circle means I do not, so it goes up till -8 and then a parenthesis at the end because you don't include -8 because it has an open circle. And that's the interval notation. That means all the x values fall between -infinity and -8 that make the inequality true. And the last one we'll look at is set builder notation. So set builder notation, we start with a curly brace, remember, because sets always have a curly brace. The variable, which in this case we called x, so we'll call it x here. The bar, that means such that, so it's a set of all x such that, and then the condition, which is x is less than -8, curly brace at the end, closing it off. Keeping in mind that, in this example, I didn't ask you to solve for anything, right? We're just writing this solution they already gave us in the notations. Typically, this will be the end of a problem where you actually had to solve, like we did at the beginning. Let's take a look at this compound inequality. If I had -4 is less than x is less than or equal to 3/2. Again, it's already solved for you. When you see these compound inequalities, ideally, if you see these three parts, you want your variable in the center, in the middle, because it's going to give you an interval. And when I look at this number line, what you're going to do is you're going to put both values that you have here as your boundaries on the number line. So I have -4 and I have 3/2. Don't let it being a fraction throw you off. It's still a number, just like anything else. It goes on a number line. Remember, smaller numbers to the left, larger numbers to the right, so it has to be in the correct order. And then let's talk about what happens at each point. We have -4 is less than x. So what that's really telling me is -4 is smaller than the x values. But the other thing is that there's no equal to. If there's no equal to, that means you have an open circle on the -4 because you're not including it. So it says -4 is less than x. Now remember, x is the variable. We don't put it on the number line. Sometimes people try to write it in somewhere. They put like a little tick mark on here with the x. Remember, x is the variable. It's actually representing any number that meets these requirements. It's not a specific number. And then x is less than or equal to 3/2. Well, we have an equal to, right? X is less than or equal to 3/2, so I know I'm including the 3/2. That's okay. And then you have to ask yourself, well, where are these x values? Well, these x values are in between. -4 is less than x, so it's smaller than x, but x has to be smaller than 3/2. So where does that end up being? That's in the middle. And typically you can see that, right? X is in the middle. You know it's in the middle there, but it's really saying -4 is smaller than x, which is smaller than these values here, which is smaller than 3/2. And that would be your number line. The interval notation, let's talk about that. Left to right, where's my solution? Well, we start at -4, but there's an open circle, so I don't include it. So you want to start with a parenthesis, because you're not including it. -4, comma, how far out to the right does this go? Well, it goes up to 3/2. So put 3/2, and then do I include 3/2? Well, it's a closed circle, so yes. So use a square bracket on there. So remember, using a square bracket, if it's included, use a parenthesis if it's not included. The other thing I'd point out is that at the beginning of this, I had parentheses at -4. You don't start like at -3 just because you're not including it. Because remember, there's numbers between -4 and -3. So all those really small values, really close, like -3.99999 are included. So you have to start with a parenthesis, -4, and then going out to 3/2 bracket, because 3/2 is included. It's equal to in your answer. And lastly, we'll do the set builder notation. I'm going to use SB for short, so I have to write it every time. Alright, so set builder notation, again, always starts with a curly brace. The variable, in this case our variable is x. The bar, that means such that. Now in this case the condition's a little different because it's giving you an interval from -4 is less than x is less than or equal to 3/2, right? You have this compound inequality here, which we'll talk about later. But the point being is that it's still the condition. X has to be between -4, not including -4, up till 3/2, including 3/2, right? These mean the same thing. This set builder means the same thing as this interval notation. It means the same thing as that number line. So there's just different ways to express your solution, but the solutions are all the same. So pay attention to what the directions are asking you to do, because you might be asked a variety of different ways to express your solution. Let's talk of a special rule when you solve inequalities. Alright, so this is a special rule. When solving inequalities. And what it basically says is if you divide or multiply, but more typically it comes up when you divide, by a negative number, when solving. An inequality, then you must switch the direction of the inequality symbol. So, if you multiply or divide by a negative, and typically it's going to be division when you're solving, but it could be multiplying. But if you multiply or divide by a negative number when you're solving an inequality, then you must switch the direction of the inequality symbol. And when I say that, let's make sure you know what I mean. What I'm really saying is, if I had a greater than, it becomes less than. If I had, a less than or equal to, it becomes greater than or equal to. So you're just switching the direction of it. You're not changing if it has equality or not. Right? And then vice versa on these as well. So keeping in mind, this is only when you divide by a negative number. All right? It's not if there's a negative number in the inequality. It's if you divide by a negative number or if you multiply by a negative number. So we'll solve a few of these. Sometimes the rule will apply, sometimes it won't. So if I said to solve, and the first one I'll look at is negative 8x minus 7 is greater than 17. And we solve, as I mentioned earlier, you want to try to isolate x on one side of the inequality. Typically these are easiest if x is isolated on the left side, just because it helps you when you're going to draw your number line and write the interval notation, but you don't have to have it that way. In this case, to isolate the x term on the left side, I'm going to add 7 to each side. So it's just like when you're solving equations, except for you have an inequality symbol, make sure you keep the symbol. So you have negative 8x is greater than, keep that greater than, and then 17 plus 7 is 24. And then solving this, right, you want to divide both sides by whatever the coefficient of x is. In this case, a negative 8, so you divide by negative 8. Divide by negative 8, so you'll get x is, now remember, when you divide by a negative, which we just did it, that's our special rule, you have to switch the direction of the inequality symbol. So this is going to be x is less than 24 divided by negative 8 is negative 3. So x is less than negative 3 is our solution. Remember, this was the key step because I divided by a negative, so I switched the direction on that inequality symbol. So we have x is less than negative 3. And part of the reason why we do this, when you divide by a negative is that you're really kind of flipping your number line. So if you're flipping your number line, your inequality numbers don't hold. In other words, your positives become negatives, your negatives become positives. So your inequalities are going to be facing the opposite direction. Really, just make sure you know the rule, though. So I have x is less than negative 3. Now, if they ask you just to solve, you can just give the answer. Typically, they'll ask you to solve and give your answer in a certain format. I'll write out all the formats we've talked about just so we know how to do it for each of them. Make sure you're paying attention to the directions so you know which way they want you to state your answer. So for a number line, on our number line, we only need one value in this case, which is negative 3. Remember, if they gave you a 0 on the number line, make sure you put negative 3 to the left of it. So we got negative 3, and we want x's that are less than negative 3, so I'm not including negative 3, so open circle, right? So there's no equal to, so you're just open circle on there. X is less than negative 3 means smaller than. Smaller numbers are to the left on a number line. And one way sometimes people remember this is that they look at the inequality symbol you have here, and that less than, like that kind of looks like the arrowhead at the end of going to the left. This only works if you have your x's on the left of it, though, at the beginning. I like to think about it just in terms of where it would be in terms of x is smaller than negative 3, right, or less than negative 3. So I would shade the left side because the lower numbers are to the left, the higher numbers are to the right on a number line. All right. Let's talk interval notation. Interval notation, easiest to grab that from your number line. Starting from the left, how far out to the left does this go? Well, it goes out forever, so it starts at negative infinity. And remember, if we start at negative infinity, do I use a parenthesis or a bracket? Well, I use a parenthesis because you can never include negative infinity, so it's parenthesis, negative infinity. How far out to the right does it go? Well, it goes up to negative 3. Do I include negative 3? Well, it's an open circle, so I don't, so I know I use a parenthesis there. And let's talk set builder notation. Set builder notation. Remember, curly brace you always start with for a set. What's the variable? Well, in this case, it's x. We need the bar, that means such that, and then the condition, which is x is less than negative 3. close the curly brace, and then you've got it. Make sure you don't put the original answer in here, or I should say the original inequality in here. Right, you only want the solution in here at the end. Same thing when you're doing the number line. You're only looking at the solution. You're not looking at the original inequality. Let's take a look at another one here. If I had 6 minus 3p is less than or equal to 18. Again, we're trying to solve this inequality. To solve this, you want to isolate the variable on one side. So I'm trying to isolate this negative 3p term first. So to move this positive 6 so it cancels out, I need to subtract 6, so negative 6. If I do it to one side, you have to do it to the other, right? So we subtract 6 from each side. I end up with negative 3p is less than or equal to 18 minus 6, which is 12. Once I'm here, you're trying to solve for p, so I have to divide by the coefficient, which is dividing by a negative 3. Divide by negative 3. Now remember, we divided by negative, right? We divided by negative 3 down here. So that's our special rule, right? That tells us we're going to want to switch the direction of the inequality symbol. So we got p, because the negative 3's cancel. Now instead of this being less than or equal to, it becomes greater than or equal. Make sure you keep the equal with it. And then 12 divided by negative 3 makes this a negative 4. So my solution, right, the answers that make the original inequality true are values for p that are greater than or equal to negative 4. And then we'll draw our number line and state our answer in the other notations. So for the number line, make sure you draw it out. Let's put our value on here that we need, which is negative 4. And let's talk about if it's included or not. So if I've got p is greater than or equal to negative 4, the equal on there tells you do want to include negative 4, so it's a closed circle. All right, we want p values that are greater than or equal to negative 4. Well, greater than means larger than, right, negative 4. Well, where are the bigger numbers on the number line, from the left or the right? Well, the bigger numbers are to the right, so we know we're shading that way. So those are the p values that are greater than or equal to negative 4. And then we can talk about interval notation. And typically, the question will ask you to state it in one or the other, not interval and set builder. I'm just doing them for both so you can see how to do it for each of these. So for interval notation, remember, look at your number line from left to right. Well, from the left, where do I start? Well, I start with negative 4, and do I include it? Well, a closed circle says, yeah, you do, so you want a bracket, right, a square bracket, and then negative 4, comma, how far out to the right do you go? Well, you go out forever, right? That arrow means you go out to infinity. Now remember, can you ever attain infinity? The answer is no, because infinity is more of an idea. You go out forever. It's not a number you can get to. And then it's a parenthesis, that means, because you can't include infinity. So you only put the bracket on the side that's being included. You don't put it on both sides necessarily, unless they were both included. And then the last notation, set builder notation. Remember, we'll only ask you probably for one or the other, not both interval and set builder. For set builder notation, you want a curly brace. The variable in this case, make sure you put the correct variable. It's p. The bar, that means such that, and then our solution, which is p is greater than or equal to negative 4, and then close the curly brace. If you're doing this in MyMathLab, you can find the square brackets and the parentheses on your keyboard. Sometimes people can't find those for the set builder notation. They usually give you the curly braces, but those are also on your keyboard if you needed them. Let's solve just compound inequality here. If I said to solve 4 is less than or equal to negative 2x plus 6 is all over 3 is less than 8. So when I'm solving something like this is a compound inequality. I really want to try to isolate the variable in the middle if I can. And, if you're solving an equation that had fractions, one of the first things we learned was that you would want to try to find the least common denominator, the lowest common denominator, and multiply it to every term because that would clear fractions. You'll do the same thing here. So if you notice that this has fractions, right, the first thing I'm going to do is try to clear fractions by finding the LCD. The LCD in this case, well, it's the only denominator you have is 3. If there's more than one fraction, you want to find the LCD of the whole thing. And what you do is you want to multiply every term by 3. And, this is 2 different sides. There's, 3 parts of this, right? Here, here, and here. Every term gets multiplied by 3. So you'd have 3 times 4. It's less than or equal to 3 times negative 2x plus 6. This is all over 3, which is less than 3 times 8. And remember why we're doing this. We're doing this because we're actually trying to clear fractions, right? So if it doesn't have a fraction, you just multiply them together. So like 3 times 4, that's just 12. It's less than or equal to, here, 3 times this negative 2x plus 6 all over 3. I wouldn't distribute the 3 through. What you really want to do is divide 3 by 3 first. That cancels to a 1. And then 1 times whatever's left here. 1 times negative 2x plus 6 is just negative 2x plus 6. So remember, the goal was to clear fractions. You should clear the fractions when you can. And this is less than 3 times 8, which is 24. So now fractions are gone. It makes it a little easier to work with. Once you've done that, remember the goal I said was to get x isolated in the middle, which means that to isolate this, we do what you normally would do when you're solving an equation. So if I want to take negative 2x plus 6 and I just want to isolate the x term, I want to subtract 6 from each side. But in this case, I'm subtracting 6 from here, but I have to keep it balanced. I have to subtract 6 from all 3 parts. Sometimes people only do it to one side or the other. You have to do it to all 3 parts because there's 3 parts to this inequality. So I subtract 6 from each part. So 12 minus 6 is 6. Is less than or equal to negative 2x is less than 24 minus 6, which is 18. And then once you have that, remember, you still have to try to solve for x. You can't leave it as negative 2x in the middle. So I'm trying to solve for x. I'm going to divide by whatever's the coefficient of x's, which is negative 2 in this case. Divide by negative 2, divide by negative 2 to all 3 terms. But noticing our special rule. When you divide by a negative number, you want to switch the directions of the inequality symbol. So if I'm doing that, 6 divided by negative 2 is negative 3. This less than or equal to becomes greater than or equal to negative 2x divided by negative 2. Well, that's just positive x. That's why we did it. Remember, you have to switch this inequality symbol as well. So this becomes greater than, because it was a less than before. 18 divided by negative 2 is negative 9. Now, when you see this, it might look a little unfamiliar. You got negative 3 is greater than or equal to x is greater than negative 9. This is a solution, right? This is the correct answer. But it's kind of out of order because you have the larger numbers on the left and the smaller numbers on the right. It's okay to leave it like this, but more typically, you're going to rewrite this. Now, I'm just saying this is a rewrite. You're not doing anything except for reading it backwards. So I'm going to write it from smallest to largest, because right now, remember, we're negative 9, and if I was to draw you a number line, where negative 9 and negative 3 fall. If here's negative 9, negative 3 is larger than it. So right now, this is kind of in the opposite order of what we want to see it. So if I rewrite this from, the smallest to the largest, I'd be starting with negative 9. We're just reading this backwards. We're not switching symbols. We're reading it backwards. So it's negative 9 would be less than x, which is less than or equal to negative 3. It's still saying the same thing, that x falls between these, right? Negative 3 is bigger than x, is bigger than negative 9. It's the same as saying negative 9 is smaller than x, which is less than or equal to negative 3. More typically, though, you'll see it written from lowest to highest. So I would recommend rewriting it. It's okay if you leave this as long as you understand how to use it later. So once you have the solution, all right, so negative 9 is less than x is less than or equal to negative 3 here. Now we can draw our number line. So our number line over here, maybe I'll just use the one I already set up. You want to have your values on there, negative 9 and negative 3 in the correct order, right? Smallest to largest. And then, we want to fill in the circles based on if we include them or not. So negative 9 is less than x. There's no equal to on there, so it's an open circle. And x is less than or equal to negative 3. There's an equal to on there, means negative 3 can be included, so it's a closed circle. And where are the x values? This is telling you the values of x that, satisfy this solution fall between negative 9 and negative 3. That's why the x is in the middle. So the solution is all the values between there. Any value for x between negative 9, not including negative 9, but include up through and including negative 3 will satisfy the original inequality we had up here. So that's the answer on a number line. Let's talk interval notation for interval notation, looking at your number line is probably the easiest way to do this. From left to right, starting on the left, -9 has an open circle there, so I'm not including it, which means I start with a parenthesis, -9. And then we're going up till what value? Well, this goes all the way up until -3, so comma -3. Do I include -3? Well, it's got a closed circle, so that's a yes, so you put a square bracket on that side. So the interval notation goes from -9 to -3, not including -9, that's why there's a parenthesis, including -3 with the bracket. And the last notation, we'll look at a set builder notation. Remember, set builder notation starts with a curly brace. So we'll have curly brace, and then the variable, which in this case is x, the bar, that means such that, and then the solution, which we have as -9 is less than x is less than or equal to -3. And then we've got it written there. So let's just take a look at one more here just to make sure we got it down. Alright, so you might want to try this example by pausing the video and trying it on your own first. So if I said to solve -4 is less than or equal to 3x plus 5 all over 7, which is less than 8. So, first off, solving this, you have an inequality with fractions. The first thing I would do is look for a least common denominator. In this case, the LCD, it's just the only denominator you have is 7. So it's 7. I want to multiply to all terms, remember, because that's what's going to help me clear fractions. So I'm going to do 7 times -4 is less than or equal to 7 times the 3x plus 5 over 7, which is less than 7 times 8. And then remember, you just multiply it to terms that are just, whole numbers or integers, and then you clear fractions when you can. So 7 times -4 is -28, is less than or equal to 7 divided by 7, here cancels to a 1. 1 times 3x plus 5 is just 3x plus 5, which is less than 7 times 8, which is 56. And once you're here, fractions are gone. Now remember the goal when you're solving one of these compound inequalities, they've already given you the variable in the middle. You want to keep the variable in the middle, but isolate it. So 3x plus 5, if I wanted to just isolate this to x, I needed to isolate the 3x term first. So I'm going to subtract 5 from each side. And remember, each side, there's 3 sides here. Make sure you do it to all 3 parts. And you have to subtract the 5 first. Don't try to divide by 3. It'll change things. So you have to isolate the x term. So we're subtracting 5 from each part. -28 minus 5 is -33. Is less than or equal to 3x plus 5, and then minus 5 cancels. That's why we did this, right? So you've got 3x. And this is less than 56 minus 5 is 51. Once you're here, we want to isolate x in the middle. So this is 3 times x. Remember, we divide by the coefficients. We divide by 3, divide by 3, divide by 3. You have to do it to all 3 parts. -33 divided by 3 is -11. This is less than or equal to 3x divided by 3 is just x. That's why we did it, is less than 51 divided by 3, which is 17. Now, something to point out, we did not divide by a negative value here, so I did not change the direction of my inequality symbols. In our previous examples, the last few we've done, we did divide by a negative number. So it's what you divide by. It has nothing to do with there being a negative in the problem, right? Just because it was -33 doesn't mean I switched the symbols, because these values of 3 are all positive I'm dividing by down here, that the symbols stay the same. If these were -3s that I was dividing by, then these would switch. So this is actually the solution. -11 is less than or equal to x is less than 17. It's telling you that the x values that make this original inequality true are between -11, including -11, up until 17, not including 17. On a number line, I'm going to put our values on there. So we'll put -11 and 17 in the correct order. I want to include -11 because there's an equal to on it. So close circle. On 17, not included because there's no equal to on the inequality. So it's an open circle. And the x's are in between. So we're in a shade in the middle. And that'll give us our number line. Usually a number line is helpful in drawing the writing the interval notation. So even if they didn't ask me for a number line, but they asked me for interval notation, I'll probably draw the number line anyways. It makes it easier to work with. Interval notation, remember from left to right, smallest to largest always. Starting on the left, the first number I use, I'm at -11. There's a closed circle, so that means I include it. So it's a bracket, -11. Up until, how far do I go? Well, I go up to 17. Do I include 17? No. So it's a parenthesis. So that's our interval notation. It says you start at -11 including it, up to 17 not including it. And then our set builder notation. Remember for a set, you always start with a curly brace. And then the variable, which in this case is x, so it's the set of all x, the bar that means such that, and then my solution, -11, is less than or equal to x is less than 17. So hopefully this video helped show you how to solve inequalities. Additionally, I did give you examples that showed how to write it on number line, interval notation, and set builder notation. When you're solving problems, just be careful that you're answering with the notation they're asking for, because they typically won't ask you for both of interval and set builder. They might ask for one or the other. So make sure you know the difference between the two. You can't just write both of them down and hope you get credit for it. So hopefully this video helps. There'll be a follow-up video of this on compound inequalities that goes along with this section. That'll show you a couple more examples in different situations that occur.